Hello everyone and welcome to Unit 2. We are going to be looking at linear equations and inequality, and this is the pre-unit check. So you can push ahead to slide 2. On the left, so we have this like hanger thing, and it looks like a something you hang your clothes on in the closet, and we want it to be balanced on both sides. So on one of the sides we have 7, and on the other side we have a 1 and then 3 x's. And it says what value of x makes the equation true. So maybe we think it's 4. If I hit 4, we'll see that it's not balanced. We want it to be balanced. So we could try 3. Not balanced. Definitely needs a little less. How about 2? When x is 2, it's balanced. And that makes sense because, let me get my little pen. If this is 2, 2, 2, all of that adds together to be 7. 2 plus 2 is 4, plus another 2 is 6, plus another 1 is 7. Let's try another one. What would make this hanger balanced? Okay, so maybe you want to try 5. Ooh, definitely not balanced. Too big. Okay. So we can look at it and say, okay, well, this 5 and this 5, right, equal 10. So over here we have 16. If we take away 10, then we're just left with 6 that we need to figure out. And we have 2 x's that are going to add to 6. So what number plus itself gets it 6? And of course, that's going to be 3. Now, we can think about these visually and think about the balance, but we can also solve these using algebra. So on the left, we have 2x plus 2.2, and we want that to be equal to 6.8. So what we can do is we can subtract, do the opposite operation, and subtract 2.2 from both sides. Whenever we're trying to solve these types of equations, we want the x to be alone. So here's our x. So we want that to end up being completely alone. So first we'll get rid of 2.2 by subtracting it. So then we're just left with that 2x equals 6.8 minus 2.2 is 4.6. This is 2 times x when it's attached like that, so we can divide both sides by 2. 4.6 divided by 2 gets us 2.3. So that means our x must be equal to 2.3. Let's plug it in and check it, and we'll see that that does work. Now, there's a bunch of these problems. If this is helpful to you, try again, do as many as you want to figure out what would make x true. When you're all set, push ahead to slide 3. Solve each equation, use paper to help with your thinking. So for the first one, we have x minus 1/2, equals 12. So we want x to be by itself. So we need to get rid of the minus 1/2. To get rid of it, we need to do the opposite operation and add it to both sides. Whatever we do to one side, we have to do to the other. Negative 1/2 plus 1/2 cancels to 0, and we're just left with x equals 12 plus 1/2 is just 12.5 or 12.5. So we can do 12.5. Great. For the next one, we have negative 1/2 times x equals 12. These are being multiplied. When we have a fraction like this, if we multiply by the reciprocal, I'm just going to make this a little smaller. Hold on. Okay, so we're going to multiply it by the reciprocal. So flipping this fraction, we'd get negative 2 over 1. And when we do that, the negative 2 divided by 2 cancels, negative 1 divided by 1 cancels, and we're just left with x. 12 times negative 2 is negative 24 over 1, which is just negative 24. Okay. And let's look at one more. We have 1 minus x equals 12 minus 2x. So we want to get those x's on the same side together. So I might add x on both sides. Negative x plus x cancels to 0. So we have that 1 equals 12. Negative 2x plus 1x is a negative 1x. And this 12 is positive, so I'll subtract it to get it to the other side. And then we have negative 11 equals negative x. If they're both negative, multiply everything by negative 1, and you just get x equals positive 11. When you're all set with this, push ahead to slide 4. Okay. Slide 4, it says select two expressions, write their sum using the fewest number of terms. So we can select any two expressions. So I'll take this one and this one. So I grabbed this equation, and we're going to do their sum, which is talking about addition. So when we're combining like terms, we have an 8x and a negative 2x. So 8x minus 2x is 6x. And then we have a positive 8 minus 2, which is 6. So we have 6x plus 6. Check my work. Select the two remaining expressions and write their sums. So for this one, we have negative 3 plus 3 times x plus 1. I would distribute this parentheses first. So we have our negative 3 plus 3 times x is 3x. 3 times 1 is 3. Negative 3 plus 3 cancels out to 0. So we're really just left with 3x. Yay. Perfect. Once you have those two all set, push ahead to slide 5. Expression using the fewest terms possible. So we have 2 parentheses times x plus 3, close the parentheses, minus 5x plus 2. The quickest way to go through this, we want to distribute. That 2 is outside, knocking on the parenthesis door. It needs to come in and be multiplied by the x to get us a 2x. And then 2 times 3 is 6, minus 5x plus 2. So we have our like terms is a 2x minus a 5x. 2 minus 5 is a negative 3x. And then we have this positive 6 plus a positive 2. 6 plus 2 is 8. So our simplified expression is negative 3x plus 8. And you can hit submit. And then push ahead to slide 6. On slide 6, we have one solution, no solutions, or many solutions. So with these options, with this one over on the left, 2x plus 6 equals 2 times x plus 3. When you distribute this 2, you end up getting 2x plus 6 equals 2 times x is 2x plus 2 times 3 is 6. And what you'll notice is these on the left and the right are actually the exact same. That is an example of many solutions. when they end up being the same on the left and the right. We can plug in any value for x and we'll get a true statement. This one, x plus 3 equals x plus, or x plus 6 equals x plus 3, is an example of no solution, because we cannot have an x and add 6 to it and then also add 3 to it and have it be the same on both sides. It won't work. And then finally, over on the right, x plus 6 equals 2x plus 3. We could subtract 6 on both sides, and we'd get x equals 2x. 3 minus 6 is a negative 3. Minus 2x to get our x's on one side together, and we'd get negative x equals negative 3, which is x equals 3. So that's an example of one solution. There's one x value that will be a solution there. Once you have this all set, you can see the difference between one solution, no solution, or many, and then push ahead to slide 7. So on slide 7, we have an equation of y equals 1/2 x plus 3, and it wants us to complete the table with 2 solutions to the equation. So as a reminder, our axis that goes left to right is our x-axis, and our axis that goes up and down is the y. When we are writing a coordinate, we always do x, comma, y. Alphabetical order, x comes first. So if we know that our x is 4, here's 4 on the x-axis. We go up to the line and we see it hits the line here, and at that point our y value is 5. So this is the point, 4, comma, 5. Now if we did that again, if we know our y is 12, 12 is all the way up here. Ooh, but we don't know what the x value is because it does not go that far over. Well, we can take 12 and plug it in for y into our equation. So we get 12 equals 1/2 x plus 3. We could subtract 3 on both sides. 12 minus 3 is 9 equals 1/2 x. To get rid of the fraction, we multiply by the reciprocal, 2 over 1. 2 times 9 is 18. These 2's cancels, these 1 cancels, and we're just left with x. So when x is 18, y is 12. And you can see it'll blast out, and you can see that that point is correct. Beautiful. Once you have everything that you need here, push ahead to slide 8. Here's another equation, x plus 2y equals 8, and complete the table with 3 solutions to this equation. So we have x plus 2y equals 8. So let's plug in 0 for x. So if x is 0, we would have 0 plus 2y equals 8. 0 plus 2y is just 2y equals 8. Divide both sides by 2, and we get y equals 4. So one point is if x is 0, y is 4. Let's plug in x equals 1. So we'd have 1 plus 2y equals 8. Subtract 1 on both sides, and we'd get 2y equals 7. Divide both sides by 2, and we'd get y equals 7/2. So when x is 1, y is 7/2. We'll do one more. We'll say, how about when x is 2? We have 2 plus 2y equals 8, minus 2 on both sides to get 2y equals 6. Divide by 2 to get y equals 3. So when x is 2, y is 3. And if we were to graph them, we would do 0, 4, 1, to 3.5, and 2, 3. There we go. Check part 2 for the rest of the video.